In the previous video, we saw how to solve the simplest possible neural network, one that consists from two nodes. If you have not seen it, please go take a look, watch it, and then you're going to be able to understand this video a little bit better. Now, in this video, we're going to see a slightly more complicated neural network. It's still very simple, but it is more interesting than the one we have seen before because it consists of several hidden layers. In our case, our neural network will consist from 5 different nodes. These are the nodes. Let's name them x0, x1, x2, x3, and x4. These are called the hidden layers, x1, x2, and x3. x0 is the input layer, x4 is the output layer. They are connected from synapses, as we can see here, and each synapse has a weight. Let's call it W1, W2, W3, and W4. In the official notation, the mathematical notation that you're going to see in books about neural networks is a little bit different. For now, we don't want to complicate the notation. We just want to have an intuitive understanding of how things work. The notation is something that can follow. So, what we know in this topology here is the value of the input, which is x0, and we know the expected value, the correct value that we expect to find. We hope to find this value. Similarly, like what we did before with the simplest possible neural network, we define as the cost of the neural network this function here. As we have seen before, and I have one video where I calculate the derivative of this function explicitly, the rate of cost over x4 is given by this equation. And to make our life easier, we just call this quantity here delta, with the Greek letter delta. So we know that the rate of change of cost over x4 is delta. As an example, let's try to find the adjusted weight for W1 for this. Obviously, what we know is x0 and expected value, and we also know that the relation between subsequent layers is always linear. What this means? This means that, for example, x4 is x3 times W4. With the same token, x3 equals x2 times W3. x2 equals x1 times W2. 2 x1 equals x0 times w1. We're gonna use these functions here, these equations, and the rate of cost over wx4 to calculate the delta w1. How much we have to adjust w1 in order to get closer to the best possible answer. To do so, we're going to use the chain rule. What is the chain rule tells us? That if we have a function the partial derivative of y over z times partial derivative of z over x, this is the partial derivative of y over x. This is the chain rule. And this we're going to apply here as we applied for the simplest possible neural network to solve our problem. So, we do have the rate of cost over x4. Let me move this closer to our calculations so it's going to be easier for us to follow what we're doing. So we do know the partial derivative of cost over x4. And we already have seen that this is nothing else than delta, meaning that this is delta. I think this is a good starting point. Let's see why. Let's multiply this by the partial derivative of x4 over x3. Can we calculate this? Yes, we can, because from this equation here, it is easy to see that the partial derivative of x4 over x3 is w4. In other words, here, this quantity here is w4. Let's move one step backwards again. Let's add here the partial derivative x3 over x2. x3 and x2 are connected by the equation x3 equal x2 times w3, exactly with the same logic as before. This is the w3. Let's move one step further. Now let's put here dx2 dx1. This is W2. Now we have reached this point here. What we're looking for is this, is W1. For this, we can write the following here. dx1 over dw1. What is this? This partial derivative here. Since x1 equals x0 times w1, this means that the derivative dx1 over dw1 is what? It is x0. Now, take a look, a careful look, and this, they cancel themselves. This and this, they also cancel themselves. Same here, same here. In other words, the rate of change of cost over W1 is given by the formula x1 times W2 times W3 times W4 times delta. No matter how many hidden layers we have, this formula is going to apply for all of them. Here we have 3 hidden layers. We might have 50 or 100 or 500. It doesn't make a difference. I hope this helped to understand how the chain rule allows us to calculate the cost over weight rate and how to make the related adjustments. In the next video, we're gonna see another, a little bit more complicated version of a neural network, and we're going to discuss a formula that we can use to implement a neural network, to implement the backpropagation of a neural network in coding. Thank you for watching.